everybody. First of all, thanks for the opportunity of being here presenting this work. So I am Daniel Santos. I'm going to present the work Classification Scheme for the Inventory of Geomorphosites, application to the proposed GEOPARK COSTões e Lagunas, Rio de Janeiro, Brazil. I did this work with the professors Kátia Mansur and José Seoane. We're all from the Federal University of Rio de Janeiro, from the research group Geodiversity and Earth Memory. So we all know that the inventories of geosites are basis of geoconservation strategies. And because of that importance, they depend on well-structured methods for the selection of the sites, for the evaluation of the sites, and so on. And sometimes it is difficult to organize these inventories under a systematic database, especially when you're dealing with large territories and geodiverse territories. And the definition of frameworks is already acknowledged as a way to approach that. But also the classification schemes can be valuable tools to deal with these situations. So the objective of this work is to propose a classification scheme for the inventory of geomorphosites. So we are dealing with this specific framework of geomorphological sites in the territory of the proposed GEOPARK COSTões e Lagunas, which would be cliffs and lagoons in English, located in the state of Rio de Janeiro. This proposal is considering the use of GIS, but mainly the specificities of the geomorphosites. I'll be talking about them in a few minutes. Here is the territory of this proposed GEOPARK COSTões e Lagunas. As you can see, it is a very large territory of more than 10,000 square kilometers. It embraces 16 municipalities in the state of Rio on the coastline, the southeast and northern coastlines of Rio de Janeiro state. And besides being large, it is also a very geodiverse area. So here are a few photos to illustrate that. So there are different environments, dune fields, coastal massives, mountains, islands, caves, cliffs. So this big geodiversity brings this challenge of organizing this inventory with so many different types of geosites, different types of geomorphosites. Considering the specificities of geomorphosites, according to Renat 2009, there are three main peculiarities for this type of geosite. First, the imbrication of scales, both spatial and temporal scales, because geomorphosites, they can vary greatly in terms of size, and the same geomorphosite may present different landforms within the same site. So there is this imbrication of spatial scales. In temporal terms, the geomorphosites, they may also be active, like present active process, or they may also be inherited landforms, showing evidence of past processes. So this imbrication of scales is definitely a very important issue when you're working with geomorphosites. The dynamic dimension is also really important because the geomorphosites, they may often be quite dynamic. They, due to the geomorphological process active in the area. And also the aesthetic dimension, because geomorphosites, they have this potential of attract people's attention due to this aesthetic dimension. And this is quite important as well. So considering these specificities, this classification proposal is divided in three parts. First, the spatial classification, then the thematic classification, and the temporal classification. I'll be talking about each one of these now. Starting with the spatial classification, it is divided in two parts. First, you can see in the left, it is classified as point, line, or surface. It can also be complex surface when we have different landforms within the surface. And it can also be classified as single landform, group of landforms, geomorphological complex when we have one main processes and different landforms, and geomorphologic systems when we have associated processes and landforms. In our case, we are not considering the viewpoints in this inventory because we are only considering the landforms themselves. and not the place we used to see the landforms. Here I'll bring some examples. First, this geomorphosite called São João Hill. You can see in the photo is an Inselberg, an isolated hill in the coastal plain. It's a very interesting geomorphosite related to a magmatic event that occurred around 60 million years ago that created a series of alkaline massives, and this São João Hill is one of these massives. So it's simply a surface due to the shape of the site, and a single landform. Is this single landform quite remarkable in the landscape? Here another example, the cliffs and paleocliffs of Haza Beach. This geomorphosite is related to variations in the sea level. We can see there are punctual occurrences of one active cliff in the photo, the one in the front, and in the back we can see a series of paleocliffs which were active during previous past moments of higher sea level during the Quaternary. So this is an example of group of similar landforms, punctual occurrences of these landforms. Tartaruga Beach is also quite interesting because it's a coastline that's passing through a severe process of marine erosion. So right now there are some urban features destroyed. So this coastline during the last decades is retreating. So it is classified as a line in this process of retreating due to the marine erosion. So it is a line, a single landform. Concerning the thematic classification, it is also divided in two parts. First, the forms, the landforms that are presented in the geomorphosite. So it can be fluvial terraces, coastal massives, dune fields, and so on. And the processes related to these forms. It could be aeolian, fluvial, tectonic. We are also considering the anthropic activity that modify the landscape. So this classification can be quite simple sometimes, like in this example here, the cliffs at Barra de Tabapuana Beach. We have the cliffs as the main feature of the geomorphosite and the process of marine erosion related to this cliff. So one form, one process. Here we have a geomorphologic complex. So one process, aeolian process, generating different types of landforms, in this case, different types of dunes, like barcons, barconoids, parabolic dunes, fur dunes, Nebka fields. So we have all these different forms, all related to the same process, the aeolian process that happens there. And then sometimes it can be a bit more complex. Here is a geomorphological system. All of these photos are from the same site. So we can see different environments in the same geomorphosite, like a coastal barrier with 4 dunes in this barrier, lagoons, and also the anthropic activity we can see in this fourth picture, the salinas, which are anthropic activity that creates a huge modification in the landscape. So in this geomorphosite called Vermelha Lagoon, we have different types of coastal barriers, because you can see in the satellite image, there is a double barrier lagoon system, one in the front active, one in the back inactive from the Pleistocene. So we have these different coastal barriers. We have the 4 dunes, we have the coastal lagoons. Inside these coastal lagoons, we have lagunal spits, and also the salinas, the anthropic landforms. So we have different forms, different processes within the same geomorphosite. And in this case, I'd like to highlight that the geomorphological context creates conditions for the development of stromatolites by biochemical sedimentation. And it is a very high scientific value occurrence in this site. And this is a geomorphological system, so the classification gets more complex. Finally, the temporal classification. The sites are divided into active sites, those that are presenting ongoing process, active processes. They can be inactive, presenting inherited landforms related to past climatic, tectonic conditions that are no longer active. And we are also using this concept of evolving passive geomorphosites, which was introduced by Polfini and Bolatti, 2014. This concept is related to sites presenting inherited landforms that are currently being modified by active processes. And these active processes, they are different from the processes that originated the landforms. So it's a very interesting concept as well to be used. Some examples here. There's this beautiful example of conscious beach presenting active processes. We can see the waves, the fraction of waves creating this rounded shape for the beach. You can see in the left part of the photo the formation of a tombolo as well due to the wave processes. So an active geomorphosite. Here, an example of an active geomorphosite, Jacarepiá Lagoon. This flat area was a lagoon before, during moments of a higher sea level in the past. So now it is inactive. It also presents some inactive lagunal spits inside. So an interesting example of inactive geomorphosite. Here, this beautiful site is by Victoria Point. A very nice example of evolving passive geomorphosite. This linear ridge is related to a tectonic process. From millions of years ago, there's a fault, and in this fault there are cataclasites and the tectonic breccia, which are rocks resistant to erosion. So the erosion that's happening right now, it's shaping this landform, creating this peculiar landform. So it's an interesting example of evolving passive geomorphosite. And also a really important thing to say is that geomorphosites may present both active and inactive features, like this in Cabo Frio Island. This is also an alkaline massive, similar to São João Hill, the first one that I presented. And the island itself presents an inactive geomorphosite because this magmatic event is not happening anymore. But we have within this main landform, we have these active landforms, such as erosional landform that you can see in the middle of the photo, this erosional landform. So we have in the same site both active and inactive landforms.
Here's 3 minutes, Daniel.
Okay, thank you. I'm just finishing. Here's just to show that we are doing it in a GIS database. And here there are examples of surface geomorphosites, groups of landforms, single landforms. Up you can see punctual occurrences and lines. So the advantages of using the GIS is that we can create, for example, selection filters. When we have this database organized with this classification in GIS environments, we can easily create, I brought this example of selecting coastal geomorphological systems to create an educational itinerary for schools and universities. So by having this database organized, we can easily do this type of selection, and depending on the objective we have, we can easily work with this database. So it is a big advantage of having this classification and use it within GIS environment. So just to finish, some concluding remarks. First, I believe the most important is that the specificities of geomorphosites, they demanded a specific classification scheme. So because of this fact that geomorphosites have these specificities, they have to be taken into account in the creation of the inventory. This is really, really an important thing to do. Second, the proposed scheme, it helps to deal with a large number of geomorphosites, with different types of geomorphosites. So by having this classification, it's much easier to work with this database. And finally, it is perfectly adapted to be used in a GIS environment, as you could see. So yeah, I believe that's it. Thanks a lot for the attention. And here's my email if anyone wants to discuss a bit more about it. So yeah, that's it. Thanks a lot.
Thank you very much, Daniel, for a brilliant and engaging talk. Just another reflection of the powerhouse of geoheritage that Brazil is. Wonderful, wonderful. Thanks. We shall go straight into questions and remind everyone, if you have questions, do type them on the chat. And if we've got time, we will go through them. We have a question here saying, asking if the GEOPARK is proposed is a place of petroleum exploration, and if that's true, how do you manage that situation?
Yes, first, this area is one of the most important areas of production of oil in Brazil. How to manage with this situation? Unfortunately, I won't be able to help a lot because I'm not working directly with the management of the site. I did my PhD within this area. I worked with the inventory of geomorphosites, and I was dealing specifically with these issues. But so this management aspects, I ain't sure if I'm the right person to talk about specifically concerning the petroleum explorations. So I'm sorry, I'm not able to answer this question properly.
Not a problem. There is also lots of people posting saying, wonderful talk, brilliant talk, lots of praise for your talk.
Thanks a lot.
There is a question complimenting your photographs and asking if you've been utilizing drones.
No, I did not use, but some of the aerial images was taken by with helicopters actually. Not by me, unfortunately. The photos were given by Kátia Mansur, which was my supervisor in the PhD and is cooperating with this work. But this is a part of the plans to start using drones.
And we have a question from Jessica who asks, what is the difference between active, inactive geomorphosites and the classification of Perfini and Belati?
Okay. The active inactive is that when you have in one geomorphosite, we have these different landforms within the same geomorphosites. Some may be active, some may be inactive. And the difference for the evolvent passive is that it's the same landform that we have these presenting an inactive process, and then an active process working in this landform itself. So like when I showed, can I come back in the slide here to show?
Click previous, there we go.
Okay, so here in PyVictoria, for example, with the same landform that is being affected by the active processes right now. And here is different because you have the island in one hand, presenting an inactive process, and this erosion of forms within the island. So that's the main difference.
Excellent. I think at that point we will carry on. Thank you once more, Daniel, for
Thanks a lot.
starting off with the first talk of session 2.